Hey everybody. I actually decided we might as well do this section uh, in Chapter 6 also. Let's do one more section in Chapter 6. Because I think it'll be good for you to have a basis moving forward with inverse functions. Now, I make a big deal about this all the time, especially with my pre-calc students, I suppose. The word inverse, you got to be very, it can be tricky. When you start your journey in algebra, or pre-algebra for all I know, you learn that there's like an additive inverse, which is really just the same as an opposite, so the additive inverse of 5 is negative 5. And there's also a multiplicative inverse, which we more commonly refer to as a reciprocal. So you could say like the multiplicative inverse of 5 is 1 over 5. And there's even other ways. There's like inverse variations. So I don't know if there's any word in math that has more meanings than the word inverse, but this is going to be the inverse of a function. So, or relations, but I guess we talk mostly about things that are actually functions. So the inverse of a function, that's what we're talking about. And so you could refer to a function as f of x. Well, the inverse would be denoted like that, with like this negative 1 looking. And one of the biggest points of emphasis I want to make is how misleading that is. I've never liked how they use this notation to represent the inverse of a function. So we have f of x, and this would be the inverse of that function, f inverse of x, with like that negative 1. I mean, it looks like a power, but here's the thing. Here's what I want you to understand. Don't let that mislead you. All right? Because normally when you have something like m to the negative 1 power, what does that actually mean? What does it mean to raise something to the negative 1 power? Doesn't that mean it'd be like 1 over m to the first power? And what you have is kind of like a reciprocal type thing. Okay? And that's why this is misleading, because the inverse of the f function does not mean you just flip it. Okay, so again, I at the risk of repeating myself needlessly, up until now, like you've known, like when you see a negative 1 that looks like it's the power, like a negative 1 power, it essentially means like you flip it. But when you're doing like the inverse of an entire function, it does not mean that. What the inverse of a function, and again repeating myself, but I don't know why they use that as the notation. Because what an inverse of a function actually means, and you know what, gang, I'm going to go to the second page here first. So I probably should have said this already, but I'm going to be doing some of these as freebies on your like assignment, and that'll be my way of showing you, like it'll be my way of notes showing you how to do all this. So anyway, here we go. I'm going to do some freebies for you. So follow along. So here's what inverse of a function actually means. When you do the inverse of a function, what you're doing is you are swapping the input with the output. Because you know how functions have input and output? It's like the input becomes output, and the output like you're just switching the input and the output. In other words, you're switching x and y. You're switching x and y. So like in number 10, for example, the way it starts out, it's the same as saying y equals 1 over x minus 2. Because remember, g of x is just like saying y. Just like, h of x, this might as well say y equals the third root of x minus 3. And down here, number 14, this might as well say y equals x plus 3. So first understand that. Okay? And then to actually take the inverse, like I said, you're literally just switching x and y. That's it. That's what it means. So in number 10, for example, your first step, and this is the big step, your first step would be to literally switch x with y and vice versa. So here we go. What this becomes is x equals 1 over y minus 2. So that's the inverse. But once you've switched x and y, now you just have to take this and kind of like resolve it for y, which is simple enough, I guess. You would start by adding 2 to the other side. So you get x plus 2, because those don't mix, equals 1 over y. Okay? Now from here, you could like do this. You could look at this as literally a proportion, like x plus 2 all over 1. And then since it's like a full proportion, you could cross multiply. Or you could like look at this as, well, let's multiply the y to the other side, and I'll do that. Y times x plus 2 would then equal 1. So I multiplied y up to the other side. And now what you would do is you would divide both sides by this quantity bubble of x plus 2. Because again, after you switched x and y, we were just basically on a mission to resolve it for y. And once I divide here both sides by this bubble, I will have accomplished that. And so 1 divided by, I don't have to actually do that because you kind of really can't simplify that. So guess what? There is the inverse. Or if you want to choose to rewrite it as g inverse of x equals 1 over x plus 2, that's fine with me. So y equals that, or the inverse of g is denoted like that, g inverse of x, or that again, that very misleading like -1 power. Number 9, first you would add 3 to both sides, right? Oh shoot, I didn't even, you fool. Full of a toque. I forgot that I hadn't even switched x and y yet. So hopefully you caught I caught you before you. So the first thing you got to do is literally switch, and the x and the y change places. Now you would resolve for y by first getting that -3 out of there. So x plus 3 equals the third root of y. And now all you have to do to get y by itself, what's the opposite of a third root? Wouldn't that be raising it to the third power? So we raise both sides to the third power. So that'll get y by itself, and over here it'll just be x plus 3 all to the third power. Or in other words, you could say what? H inverse of x. Okay, number 11. once again, this would start off as like y equals 2x cubed plus 3. And so to switch x and y, that would be x equals 2 times y to the third power plus 3. And now, once you x and y trade places, that's what inverse is all about, you would resolve for y. So I would subtract 3 to the other side, and so I have x minus 3 equals 2y cubed. Now I would divide both sides by 2. And now to finish getting y by itself, what's the opposite of a third power? Wouldn't that be like the third root? And so I take the third root of both sides. That gets y by itself on that side. And the third root, all I got to do is write it out like that. Because I can't really take the third root. Oopsie daisy. And so that's your answer, unless you want to write it as like h inverse of x. Ain't it? So that's it. So again, the steps are just have x and y, just trade places, and then do whatever you got to do algebraically to resolve it for y. That's what you're doing. I think number 12, 13, 14, 15, and 16, as well as 17. You don't got to do number 18. It's a weird graph, but and again, you don't even have to graph number 17 if you don't want to. Just kind of find its inverse. Now, the other thing about inverses, now that was the big thing, okay? The big thing I want you to know going forward about inverses of functions is that you're just literally switching input and output, x and y. If you ever had to show that two functions were inverses of each other, what you would kind of do is like let's say f of x and g of x are inverses if f of g of x equals x and g of f of x also equals x. So you would do, f of g and see if you get x, and then you would also need to do g of f, and also get x. Remember what this means. This means you are plugging in the entire g function into the f function, and then vice versa. So down here, okay, hopefully I have enough room here. F of g of x. So if I were to plug the entire g function into the f function, that would be 1/2 times, okay, so we're plugging in the entire g function in for x. 4 minus 3/2 x, and then plus 3/2. So you see how this was like 1/2 x plus 3/2, but you plugged in the entire g function. And so let's see if when you let this play itself out, what you get. So this would be distributing, obviously. 1/2 times 4 is 2. 1/2 times negative 3/2 x would be minus 3/4 x. And then plus 3/2. And you can see that, I can combine some like terms here, but, this is not going to just equal x. So I already know that this final answer is a no. No. Okay? So if you had gotten x, you would have done the other way around. You would have done g of f. And if you would get equals x both times, then they are. So give that a try. let me know if you have any questions with that. Again, number 5 and 6 don't do unless you really, really, really want to. And then same thing with number 7 and 8. Don't need to do it. Just give number 2, number 3, and number 4 a try.